Right then, so we are doing more subtraction today. We are subtracting mixed numbers and proper fractions today. So just like we did when we did our addition the last 2 weeks, but we're just going to do some subtraction. And I've already noticed, better pop that out, let's put a subtraction sign there. So, mixed numbers and proper fractions. So, job number 1 with this question is thinking about what method you would like to use. So everybody has different methods that they prefer. And if you were in school right now, we would be giving you the exact same message. You do the method that suits you. And the method that we are showing you on these videos is a more broken down method into lots of little steps so you can see each calculation. And then as you get better and more confident with solving the questions, the more you can try different methods that will be a bit quicker. Okay, so it's totally up to you. You do what suits you. So long as you get the right answer in the end, however you get there doesn't really matter too much. So, looking at this question over here then, our first job today is tackling this mixed number here. So we're going to convert this into an improper fraction. And if you remember, there are some videos on the webpage of how to convert mixed numbers and improper fractions, if you can't quite remember from the last couple of weeks. But we'll do this one together anyway. So, look at my denominator. I've got 3 here. So I'm going to say to myself, well, what is 3 times 1? Well, I know that is 3. Pop my 3 up here. And then 3 plus 2. So I'm now adding my numerator. Well, 3 plus 2 is 5. And I'm going to keep my numerator, my denominator, sorry, I'm going to keep that the same. So I've now got 5 over 3. And I'm just going to prove to you why these are both the same. Won't do this for every question, but just a little recap for you. So 1 and 2/3. Well, I've split it into 3 here because that is my denominator. So this diagram here, that represents 1, because all of them are shaded in, 1 whole. And then down here, I would have to shade in 2 of the sections, because 2 out of 3 is what we have. So this represents 2/3. So this whole diagram here now represents 1 and 2/3. And then if we look here, when we did our conversion, my numerator is 5. And if I was to go through and count all my individual squares that I have coloured, I end up with 5. Just like that. So, diagrams, they're very helpful. Sometimes if you would like to check, it's just good to see the comparison really here. So we've really got 3 different versions of the same question really. This is 1 and 2/3. This is 1 and 2/3. This is 1 and 2/3. Okay, so that's there if you need it. So we've now got 5 over 3, and my 3/5, I'm just going to keep the same for now. I don't have to do anything to that proper fraction. That's nice and simple, 3/5. So I now have to work on getting the same denominator. So there are, again, just like yesterday, there's different methods. We can multiply these together. Equally, we can think about our multiples. And think back to yesterday's video where we had the 24 and the 12. We multiplied our 2 denominators because we had 4 and 6. And 4 and 6 gives me 24, but actually 12 was my lowest common denominator. So it's always just worth bearing that in mind. It's easier to work with the smallest sets of numbers. So today I know that 3 times 5 is 15. Like so. So we're then going to do a bit of multiplying to make these fractions both over the value of 15 also. So I'm going to look over here. I'm going to say to myself, how did 3 become 15? 3 times what is 15? Now I know that that is that's been multiplied by 5. And whatever we do to the bottom, we do to the top. Whatever we do to the top, we do to the bottom. So therefore 5 times 5 would be 25. I'm going to hop over here. Same again. 5 times what is 15? Well, 5 times 3. It's the opposite of over here. We're doing the opposite, which you'll notice here. 3 times 3 is 9. So I've now got 25 over 15 and 9 over 15. So I can now go back and I can do my actual calculation. So I'm going to keep my denominator the same. I'm going to keep it as 15. And I've now got to do 25 take away 9. So if you need to do extra working out on a piece of paper or in your book, that is fine. You can do it in your head. Whatever works, but I do know that this is 16. I know 25 take away 9 is 16. So I'm left with 16 over 15 now. But this isn't my final answer because I've noticed that in my question back up here that I've got a mixed number. And if I have a mixed number in my question, my answer needs to be in mixed number form where appropriate. So I'm going to convert this now into a mixed number. Now, luckily 15 and 16 are right next to each other, which is quite helpful. So I'm going to do a little division question. So 16 divided by 15, well, I get 1. I get one lot of 15. And then it's how much I have left over. Well, I know that I have to add 1 more to 15 to make 16. I have 1 left over. And obviously I keep my denominator the same. So my final answer is going to be 1 and 1/15. This is correct, and this is correct, but this is the preferred answer, mixed number form, just like it was when we did the addition in the last couple of weeks. Okay, good luck everybody.